There are two types of hemophilia A and hemophilia B. Both hemophilia A and hemophilia B are inherited in an X-linked recessive pattern. The genes associated with these conditions are located on the X chromosome, which is one of the two sex chromosomes. In males who have only one X chromosome, one altered copy of the gene in each cell is sufficient to cause the condition. Thus, hemophilia is a disorder in which blood doesn't clot normally. The blood, if an injury happens, the blood will be oozing out, but it doesn't clot normally as in normal persons. When blood can't clot properly, excessive bleeding, external and internal, can occur after any injury or damage. This condition is known as hemophilia and it is an X-linked inheritance and cannot be treated easily. But there are people who live with hemophilia, but they have to be very, very careful. Now let's see how hemophilia A and B are inherited. The gene with the instructions for making factor is found only on the sex chromosome labeled X. If the gene is faulty, the result is hemophilia unless there is a dominant normal gene on a matching X chromosome. Hemophilia is a sex-linked recessive disorder. These kinds of defects occur more often in men than in women. Okay, a daughter gets an X chromosome from her mother and an X chromosome from her father. Suppose the X chromosome from her mother has the gene for normal blood clotting. Suppose the X chromosome from her father has the gene for hemophilia. Then the daughter will not have hemophilia since the normal blood clotting gene from her mother is dominant. It won't allow the instructions from the hemophilia gene to be sent. The daughter is then called a carrier for hemophilia. She has the gene on one of her X chromosomes and could not pass it on to her children. Look at the picture. Father does not have hemophilia XY, but mother is a carrier of the hemophilia gene. One X is a carrier, the other X is free. That is, the mother has two X chromosomes. One is carrying the gene for hemophilia, the other does not. The couple has 4 children, 2 sons and 2 daughters. See how hemophilia is inherited. In case of boys, they need only one X. So the second son has inherited that X chromosome from the mother. I told you that mother is having 2 X chromosomes. One is carrying the gene for hemophilia. That is passed to the son. Because it is transmitted through X chromosome, it doesn't mind whether Y is having or not. And so if the gene is present only on the one chromosome, that is the X chromosome, the child will be deceased. That is the second case that you see in this picture. Now look, how has the fourth child or second daughter become a carrier? Because she has inherited the deceased X chromosome from her mother. The other one is from her father and it is normal. So to summarize, hemophilia is an X-linked inheritance. Since the son needs only one X in his genome, and if he has inherited that deceased X chromosome from his mother, he becomes a deceased person. The second daughter is a carrier of hemophilia because she has inherited that deceased X chromosome from her mother, but from the father she is getting a normal X chromosome because the father is not a carrier. So there is less chance for a female to be hemophilic, because if only both the parents are having diseased X chromosome, then only the daughter will be hemophilic, but the chance for sons to be hemophilic is more. This is all what you have to learn about hemophilia. Remember how it is inherited to sons and daughters.